Okay, what are we going to cover? Basics of soil life and biology, its purpose in landscape health. Effects of pesticides and synthetic fertilizers on the life of the soil and how that ultimately causes more problems than good. Understanding fertilizers and the difference between organics and conventional. Weeds, why they grow, the relationship between them and the soil and the kind of target plants that we're trying to grow. Environmental impact of lawn and landscape chemicals. And kind of go over some kind of overview of programs for organic lawn care. So everything starts in the soil. And the only purpose of showing this slide is to say that not only are we trying to have successful businesses and have good-looking lawns and landscapes and things that are appealing to whomever we're trying to appeal to, whether it's our own homes or whether it's a city municipality or it's a private landscaping company. Ultimately we're trying to have things look in a certain way, but by being organic stewards, we're actually taking care of a much larger picture. We are responsible in a lot of ways for, the entire life cycle. It starts in the soil, the whole circle of life. It starts in the soil. Down here, when we kill off the life, kind of like in the ocean when you kill off the plankton, it affects everything up throughout that ecosystem. The same thing happens here in the soil. If you kill off the beneficial fungi and bacteria and microarthropods and nematodes, you're killing off the food source that then feeds the entire line upward, which results in a lot bigger environmental problems than just non-organic landscapes. Soil microorganisms, some of the things that we're trying to preserve and promote in the soil. Some good pictures of fungi and bacteria. And one of the reasons why I wanted to show this is look at the complexity between a fungal spore or a fungal hyphae, which is all these little tendrils that are floating around. I probably have a pointer here, so I'll have to walk in front of it. All these delicate fungal hyphae and these multiple arms coming off of a long hyphae there, versus these little rice-looking pieces of life called bacteria. When you're thinking about the delicateness of life, this down here is a far more delicate organism, and it has a much greater impact on the success or failure of an organic program when this is destroyed. Bacteria, extremely resilient. Sure, you can kill anything with enough chemicals, but the first thing that's always going to come back to life is the bacteria in the soil. And when we have an excess of bacteria, we start selecting for certain types of plants to grow. And I'm going to go into much more detail about that. But I just want you guys to have a visual in the complexity here versus the simpleness here. Some of the animals that then feed on those microorganisms all the way up the line. Okay. Josh, you can't answer any of these questions. Anybody tell me what this is? What's coming out right here? Or actually, first off, what's this? Anybody have any shot in the dark? It's actually a root. It's a root hair. These little, we got little root hairs coming off here. This is one of the main stems. Next question is, anybody know what this is out here? What kind of this sugary looking substance is? That's a plant exudate. When I say exudate, that means it's exuding it from its body. It is actually dumping sugars, proteins, carbohydrates into the soil. Why would it do that? It seems like an awful loss of energy and stuff that it had to produce itself. Why would it just dump randomly sugars and proteins and carbohydrates into the soil? Well, the reason is because this is the calling card for the microbes in the soil. The plant is sending out signals saying, I need so many of this type of bacteria, so many of this particular type of fungi. You nematode, come this way too. You look like you can grab some calcium for me. I want you to come here also. And it sends out the signal and says, if you come here, I will feed you. And if you let me feed you, I expect something in return. I want you to go out there and find the things that I need as a plant. And that's how it has a symbiotic relationship with the soil. The plant will naturally get slow release fertilizer from this relationship with fungal matter, with bacteria, with all these microorganisms in the soil. When you kill off that beneficial population of organisms in the soil, these signals go out and they're for naught. They have nobody to talk to. Or they only have a limited selection of their community to talk to. So all these bacteria show up and plants sitting there saying, I don't need you. This, you guys aren't going to satisfy what I need. I need more fungal matter. I need this, this, and that. And so the plant's then set at the mercy of synthetic nutrients to guarantee that it's going to get enough of what it needs to thrive and survive. In the nutshell, they symbiotically exist. A plant, just like in our own gut and in interior, we have a symbiotic relationship with all these flora that live in our digestive tract, even live on our skin, things that defend our body against outside invaders. And they actually help us to digest our food. Anybody here ever taken antibiotics? And then after you have your round of antibiotics, you have a hard time digesting food, maybe things just aren't feeling as great, gets massive reflux from it. A lot of that has to do with the fact that you've eliminated both the good and the bad when you've taken that antibiotic treatment. And then when you kill off all that good stuff, you're not able to properly digest food. And guess what? You're also more susceptible to getting sick. That's the same way in the plant world. When we're talking about the soil being sterilized by putting down an antibiotic, which we're going to call herbicides and pesticides, you get rid of the good along with the bad, and then you've effectively removed the digestive system and the immune system for a plant. So pesticides, if rarely are extremely specific to just going after the bad guys. Most microbes don't, carry little signs in their back that says "kill me, I'm bad," and it'll kill a wide swath of things just like an antibiotic would do. Fungicides kill both good and bad, and again, we're going to be talking a lot about fungi, because fungi are the thing that we're missing the most of in most of our urban soils. Many herbicides negatively affect the soil. Especially stuff like 2,4-D actually affects a certain type of nitrogenous bacteria that helps to fix nitrogen in the soil, leading you to actually have to use more nitrogen in order to get the same effect. Synthetic fertilizers in the form of salts, and salts negatively affect soil life. Anybody here ever pour salt on a slug? What happens to the slug? It shrivels up. You guys aren't very talkative, are you? It shrivels up and you kill it. Well, imagine all these beneficial fungi and bacteria and little succulent microbes we have floating around the soil constantly having a wash of salt floating by their bodies. You're basically pickling them. And so that salt will then compact the soil, not just because it's messing with the chemistry in the soil, but because once you kill those microbes, and the microbes are in there creating all this pore space and structure and basically fluffing the soil, then there's nothing to hold that soil apart and create that fluffiness. The soil gets more and more and more compacted. So you're killing off the good digestive system and the immune system, but you're also damaging the soil because the salt has that negative effect in multiple directions. This is something that, I don't know, Jennifer, you guys don't have any of these, do you? No. I'm planning on bringing a bunch of them because I always run out of them. This is a really cool thing if you guys are interested in really studying what biology in the soil is, why it matters, how to take care of it. It's a soil biology primer, and it was put together by the USDA along with Dr. Ingham and a few other contributors. Fantastic pictures, great graphs. It takes everything and puts it into a very digestible form. And you can get it online for free at thesoils.usda.gov. Wow. Okay, fertilizers, organic versus conventional. What is the difference? Is it nitrogen, nitrogen? I get that a lot. Is it nitrogen, nitrogen? The plant doesn't know the difference. It's always going to take it up as a nitrate. Yes, that's true. However, our soils aren't designed to have just pure nitrate dumped on it. When you're putting down an organic form of nitrogen, it's almost always in the form of a protein. So, alfalfa meal, soybean meal, fish hydrolysate, corn gluten meal, feather meal, blood meal, all these things that have the word meal in them, and the meal meaning it's the actual protein part of whatever it was derived from. Protein is made out of carbon, hydrogen, oxygen, and nitrogen. Carbohydrates are made out of carbon, hydrogen, and oxygen. It's that nitrogen from protein that becomes the organic fuel in an organic program. So you feed that protein to the bacteria and the fungi and the beneficial nematodes and protozoa in the soil. They eat that up just like we would eat up a protein. It goes through their system, and as they're living and dying and excreting, they excrete that nitrogen in the form of a nitrate. And the nitrate is then uptakeable by the plant. So you're putting down a naturally slow-release fertilizer onto the ground, and you're letting the beneficial microbes do the digesting and the processing and the feeding of the plant as that plant is signaling them to do so. The plant says, I'm hungry, putting out those sugars, those chemical signals. The different microbes in the soil start producing what that plant needs in order to keep that honey train coming. You know, they want to keep that plant happy, so it'll keep on feeding them. Oops, volume. What else do we know about salts? Dissolves easily in water, which makes it a readily available source for plants. So when you put down a synthetic fertilizer and it's in a salt-based form, you get quick response. You get to see that green up really, really fast. It's not a very long sustained green up because just as easily as it's available, it's leachable and it runs off, it seeps down into the groundwater. It's not a very sustainable form of food for the plant. It's kind of, I always equate it to, and I'm jumping ahead of myself a little bit here, but it's like I saw somebody with a Red Bull. Where's the Red Bull? It's kind of like the Red Bull for the plants versus the 4-course meal. You know, didn't sleep that well last night myself, so I've had my share of Mountain Dew today, which is not a sustainable way for me to survive. It's something that I can do once or twice here and there, and I'm going to be okay. But for the most part, I've got to cut myself off from excess amounts of caffeine, or else I'm just going to hit a wall and crash. That's the same thing when you're eating and you're feeding a plant. You need to give that plant something that'll sustain its digestive system and its flora and feed those beneficial microbes so it can have a sustained, healthy growing pattern versus a flush of green and then kind of a collapse back, and a flush of green and then a collapse back. It's not a healthy way for it to grow. It has an excess of nitrates in its leaves versus the structural protein that you're really going for. Dehydrates beneficial soil. I've already talked about that. Okay, so organic naturally derived fertilizers are complex whole food fertilizers, so you're not just talking about the protein like I was talking about. Even in something as simple as corn gluten meal, which I'm going to probably mention several times today. Corn gluten meal has a whole spectrum of micronutrients in it. It has an analysis of a 900, so you're getting, you know, a decent hit of slow-release nitrogen in there. But you're also getting a whole plethora of micronutrients that are sugars and other things that a plant really needs to survive and thrive, but aren't in those normal NPK spectrums. So everything from molybdenum to copper, all these different things that makes a plant healthy. These are organisms. Not a salt, therefore it's much more stable in the soil. It's not an issue for runoff or polluting or leachability into the soil. They're often derived by waste streams, which is kind of a nice environmental benefit. Corn gluten meal, for instance, is a byproduct of the corn syrup industry. A lot, you know, blood meal is a byproduct of the meat processing industry. A lot of these things are actually byproducts, so we're not using petroleum-based and natural gas-based fossil fuels in order to create fertilizers that we're then going to go down and salt and destroy the soil. We're adding things that have already been produced and need a place to go to. So the biggest crux with this, though, is that these protein-based and whole food-based fertilizers are highly dependent on that microbial life for them to be broken down. So that means, here's an example of something that's happened in the Treasure Valley. We have dozens and dozens of companies down there now that are offering so-called organic programs. And what they do is basically someone's been on a chemical program, they've been hearing all this great stuff about organics, and they really want to get on an organic program, so they call up, you know, ABC Landcare and say, hey, put me on organics. I know you guys have a program. Sure, we'll put you on an organic program. They pull the plug on the synthetics, and they just start dumping down organic nutrients. Sometimes they're completely organic nutrients, sometimes they're not. If you put, okay, let's go back to us taking antibiotics. If you take a whole food fertilizer, or you just take a good 4-course meal, and you dump it into a system that doesn't have the microbes to digest it, what's going to happen? You're just going to have food that just sits there and kind of rots. If you don't have the necessary beneficial microbes in the soil to break down the organic nutrients, you're going to have a failure for an organic program. You have to address the digestive system first before you add the nutrients to break down and have that become available for the plant. So that's the downside of organics. If you don't address the biology, you're not going to have a successful program. And I think that's where, for me, when I was farming, that's where my entire paradigm took a 180. I was dumping all these organic nutrients down and not seeing the results from it. It wasn't until I started using compost teas and specific types of beneficial compost that I knew had a good analysis to it, that I actually started seeing results from my organic program. That's when I also started seeing less weeds, less pests, and almost no disease. Because just like those microbes are a benefit to us in keeping us healthy, they keep the plants healthy. They actually defend the plant from negative organisms. They're like the white knights at the castle there. They are going to fight off any of the negative fungi or bacteria or anybody that tries to come in and cause a problem, because if that plant goes down, their food source goes down. I have a tendency to anthropomorphize my bacteria and fungi. I apologize for that, but that's the way I go. I already talked about this. So energy drink, quick burst of energy, but no staying power without another energy drink. Too many begin to deplete your health, nothing to build a strong foundation on. Versus a four-course meal, you're talking about slow release, sustained energy, building blocks without the burnout. Okay, rug on a drug. So our objective, in the land care industry, let me stop here for a second. Who here works for in the landscaping industry? How about municipalities? Who am I missing? Ag? Did I get everybody there?
Homeowners.
Homeowners. How many homeowners here? Okay, so we're all in the business then, for the most part. Well, you are too in a lot of ways. You're in the business to keep things looking good, and to provide. You've got an objective to keep things green at a certain time of year, keep them weed-free, disease-free, pest-free. What happens when we start doing it on a synthetic system is your objective is to make grass green, free weeds, disease, and pests. The conventional arsenal is going to be salt-based nitrogen for quick green up, herbicides, pre-emergent, broadleaf control, systemics, and burnouts, fungicides, and pesticides.
What is a burnout? What does that mean?
A burnout?
Yeah.
A burnout is kind of is anything that'll kill anything succulent. It'll be like a desiccant. For instance, a natural burnout would be like a vinegar.
A non-selective herbicide.
Non-selective herbicide. Yeah, something that'll kill anything that's succulent. Too much nitrogen causes luxury consumption and excess nitrates in the plant tissue. Okay, apologize again for this kind of remedial analogy here, but if you were to place a plate of broccoli and a big chocolate cake in front of a 2-year-old, which would they eat first? Chocolate cake. The broccoli, if you put the big plate of broccoli and they were hungry enough, they'd eat that plate of broccoli and they'd get all those good nutrients out of it. But they're going to consume that chocolate cake down to the plate before they even take a look at the broccoli. Nitrogen is the same way for plants. When a plant senses nitrogen in its environment, it recognizes it as being a finite resource, something that's easily burnt off, something that's easily leachable, and not always available. Sometimes it's only available during a certain season in the plant's kind of understanding of where it's getting its nutrients from. So it sees that excess of nitrogen, and it sucks it up like crazy. It'll suck it up so fast, it'll ignore all the other beneficial nutrients, including things like iron and calcium and copper and all these other micronutrients that are essential for the plant to grow. But it's going to take up all that nitrogen first, and it causes this phenomenon called luxury consumption. If anyone's ever grown a garden and had a tomato plant that put on tons of greenery but no tomatoes, you had too much nitrogen, because that plant will take up more nitrogen than it needs just because it's afraid it's going to be gone eventually. So when you put down all this nitrogen and it sucks up all of it into its system, it doesn't have the chance, or it doesn't have the actual building blocks to convert that nitrogen into protein, which is how a plant wants to naturally store nitrogen in its body, in its tissues, in a protein form. So it starts dumping it into its leaves and tissues in the form of a nitrate. That's when you actually seen in agricultural reports saying that there's a lot of spinach out there that's had nitrate problems with it, because they dump down a lot of nitrogen onto the soil and the plant doesn't have enough time or the building blocks to actually put it into a healthy form. It just starts holding it into its leaves in a nitrate form. The root systems are weak from too much top growth. You get this in grass, you get this in in ag, if you know, when you're growing corn even. More mowing is needed. Plant looks green, but it's weak and attracts pests and disease in the first place. Aphids and a lot of other non-beneficial insects are attracted to the smell of excess nitrates in a plant tissue. So, you know, by feeding it too much nitrogen in the first place, down in the Treasure Valley, one of our big issues is billbugs. You got some billbugs up here?
A few.
A few? One of our big issues is billbugs, and the lawns that I see the most billbug on, inevitably are the ones that have been heavily treated with synthetic nitrogen, because they just love the smell of synthetic nitrogen. Well, not so much synthetic nitrogen, but the nitrates that have built up in that plant tissue. Too much nitrogen equals attracting billbugs. Weeds thrive on excess nitrogen and poor soil. You feed weeds a lot faster when the nitrogen is readily available. As a result, you have to apply pesticides, you have to apply herbicides. Pesticides, herbicides, and fungicides kill the pests, but they also kill the beneficial soil life. Plant no longer has the proper microorganisms to digest nutrients, provide immunity, resulting in the need for more synthetic nitrogen, more pesticides, more herbicides. What I'm trying to kind of paint the picture here is that the more you use chemicals, the more you have to use chemicals. And it's kind of pulling that rug off the drug. It's kind of a weaning process, and sometimes it's not all that pretty when it happens, because when you have to teach something to relearn how to eat, you go from having a lawn that may look really good but is not very healthy to having it look not as wonderful initially before it starts coming up again after the soil's been built and the digestive system, the immune system has been established. So it's a matter of pulling the rug off the drug so you don't have to be in this continuous cycle. Now I know I have no idea about the industry up here, but I know down in the Treasure Valley, there's, you know, a lot of people's business plans are built around that. The fact that you are going to be applying those herbicides, and it's part of the program and it's part of the profit stream. And I'm not here to say that, you know, I want to see you guys make less money, because I don't. But there are other ways to then, you know, it'll cost you less because you're not going to have to apply herbicides and pesticides nearly as often. And you can charge a little bit more because you're providing a service that is actually something that the homeowner wants more than a conventional service. What does it do to the soil? So this is a picture of some soil that has been chemically treated. What I want you to notice is the cracking. Right here, you see very little soil structure. It's really hard and compacted. What few roots we see, they're really just kind of located in the first inch to inch and a half of the soil. They're not getting very far down in. The cracking is not a very good sign in any soil. You don't want soil to have cracks in it. That means that there's a calcium-magnesium imbalance. Keep that picture in your mind. It's hard and compacted from years of chemical treatment. This kind of soil, once it's been chemically treated for as long as it's been chemically treated, you have to somehow or another relieve that compaction in order to not have an unhealthy system. So what do you have to do? You have to come in and you have to mechanically aerate. A lot of companies in the Treasure Valley recommend aeration 2 to 3 times a year. And that's just completely unnecessary in my book. When we take on a client, what we do is we aerate the first year, because it helps us to move the program that we're putting down into the soil a little bit faster. Maybe the second year, if they've got really bad soil and they've been chemically treated for a long time. By the third year, we don't need to do the aeration anymore because the microbes are doing the aeration for us. They're in there actually fluffing the soil from the inside out. You don't need to constantly be doing that to a healthy soil. Mechanical aeration is really to relieve compaction from an unhealthy soil. Feel free to interrupt me at any time too, by the way. I've got something pertinent to what we're on. And I'm going to show you the slide in a little bit here about what happens after you then turn that soil onto an organic program. Okay, so what happens in anaerobic compacted soil? Anybody here not know what the word anaerobic means? Just for the sake of it, so aerobic means with oxygen or loving oxygen. So when you're doing aerobics, you know, you're actually trying to work out in such a way that you're effectively utilizing oxygen in your body. If you work out too hard and you're breathing too hard, you start going into anaerobic respiration, which is not beneficial for your heart and all that kind of stuff. In the soil, we are trying to grow aerobic, oxygen-loving microorganisms. The anaerobic, or oxygen-hating organisms, are almost all of the disease-causing ones. So all the ones that have bad smells to them, especially when you're looking at, if you pick up a chunk of soil and it smells bad, that means it's gone anaerobic. If you pick up a chunk of soil and it kind of smells earthy, a little bit sweet, that means it is aerobic. We're always trying to encourage the conditions in the soil which will propagate the aerobic microorganisms and get rid of the anaerobic ones that cause the disease. But the decomposition of organic matter in an anaerobic type situation starts to produce negative chemicals like alcohol. Alcohol is the result of anaerobic decomposition, even when we're doing it intentionally. You know, when we're making beer and wine, it's anaerobic decomposition of yeast and sugar that's creating alcohol. Well, when you deprive the oxygen out of the soil, you start to create alcohols as well. Alcohol is something that plants don't like. And if you have compacted soils with a lot of alcohol being produced in those lower levels, the plant's going to take its roots and pick them up and try to start going this way where they can find more oxygen and where the alcohols will not be produced. And that's why sometimes if you take a shovel full of soil in a yard that has a lot of anaerobic decomposition and you pick it up and you turn it over and it looks kind of just sopping wet or it just stinks and it's hard and compacted, you're not going to see a lot of roots down there because they don't want to go down that far. Now the problem is water can't properly infiltrate. If your soil is so compacted that the water's having to run off and you're getting standing water, then those roots aren't going to get any deeper either. If you don't have deep roots, then you have to water more often, and you're not going to be able to have your plants actually access all the nutrients it needs from all the different levels in the soil. What grows in compacted, chemically treated soil? Like I was talking about earlier, good fungi are the first ones to go. When you do damage to a soil, the fungi die and they don't repopulate very easily. The bacteria have a tendency, some of them will die too, but they repopulate quite quickly. However, not all plants like bacteria, and here's where our weed problems start coming in. This, I'm sure you've seen this many, many times, Josh. This is the successional chart for soil food web biology. Anybody ever been to Hawaii? On the Big Island, you have Mount Kilauea. Let's keep that in our mind. It's a big spewing volcano. Brand new soil being birthed from the heart of the earth. It's spewing out. Nothing's living on it yet. It's basically sterile. It's just not even organic matter. It has some carbon and some other minerals in it, but it's just hard, brand new soil. So that's up here. 100% bacterial. The first things that are going to jump onto that brand new soil out of the center of the earth are going to be bacteria because they're the most easily lowest form of life that can start breaking that down. A few tens of thousands of years go by, we start attracting a little bit higher levels of bacteria and microorganisms. And what we start seeing here, this F to B means fungal to bacterial. So fungal to bacterial ratio is what we're going to be talking a lot about when it comes to weed control, because when you have, let's say it's 1 pound of fungi per 100 pounds of bacteria, you've got a 1 to 100 fungi to bacterial ratio. And that's where these guys start to come and break it down. Our first plants start coming in, and the first plants that come in are what we call weeds, which are actually remedial plants. And they do great in soils that have about a 1 to 10 fungal to bacterial ratio. That's when they come in, and those are the conditions that they thrive in. Those plants are fantastic plants. They are there on a mission to fix the soil. They have the ability to digest nutrients that most other plants can't do. They exude these different types of chemicals that actually can break down calcium, can break down carbon, and make it, turn it into topsoil. That takes a long, long time to do. So these guys come in, they do their job. A few 10,000 years later, maybe a millennia, we start to evolve into these types of plants. And we're starting to get a fungal to bacterial ratio of 1 to 3. The more and more evolved we get, the more and more fungi we get. Eventually we get down here to mid-grasses and vegetables, which is where, right here is where we're trying to establish most of our landscapes, at least a good portion of them. We're down to 1 to 1.5. Right in here, late successional crops grasses and row crops, we're at about a 1-to-1. 1 pound of bacteria, 1 pound of fungal matter in the soil. The more woody and the more advanced the plant, the more perennial a plant becomes, you start to even getting more fungi to bacteria in these shrubs, vines, and bushes, then it goes to deciduous trees. And then the most advanced, the most evolved form of plant life on our planet is up here in the conifer old growth forest. Ultimately, every single soil wants to get to here. It's always pushing that direction. Every plant along the way is designed to do a job in the soil to push the soil more and more and more and more this way until eventually you get up here. Well, what keeps every soil from getting there? Fire, flood, compaction, and chemicals. Because the more you damage those beneficial fungi, the less these more advanced species of plants have the opportunity to thrive. And the more these guys have the opportunity to thrive. And they're happy to come back and do that job all over again, but that's not really what we're going for when we're talking about Landcare. We're trying to get everything into here. But what we're really doing with our practices is selecting for up here. Does that make sense? So the more damage you do to the soil, the more you damage the fungi. The more you damage the fungi, the more you select for weeds. So your target plants struggle to thrive. And when I say that once the fungi are killed, it can be difficult to self-repopulate. And that's where getting down the beneficial organisms, again, becomes so important. One of the things that we have to look at, too, is what naturally grows in this part of the world. Not much of what we're trying to make grow. What we're trying to grow is stuff that grows on the East Coast or down south or in areas that have far more organic matter in the soil or far more rainfall. We're trying to establish plants here or crops that aren't native to this area. Native plants, you can do, just throw them out and they'll do fine with the natural fungal to bacterial ratio out there. But if we're trying to evolve our soils artificially, we have to speed up the process unless we want to wait for this to do its job over several thousand years and get us down to here naturally. That's not going to happen very fast. So we need to inoculate the soils with the beneficial organisms to push this system to where we want it to be. Without a balanced soil food web, nutrients in soil cannot be mobilized. So a lot of times, like I was talking about, when the plant sends out those signals, it can send out the signal, but if the organism isn't there, the plant's not going to get the nutrients it needs because not all different types of microorganisms can actually digest every single type of mineral and nutrient out there to make it available for the plant. So if you don't have enough diversity in your soil, you've killed off all your fungi and you're just left with protozoa and bacteria, then the plant doesn't have the ability to take up the nutrients it needs. And that's when you start to see a stressed out landscape because it's not able to mobilize without the salt-based nutrients. So kind of the mission of why we're doing this here. In 1999, detected 1 or more pesticides in 99% of urban stream samples. That's pretty scary. They were detected more frequently and at higher concentrations in urban watersheds than any other watershed land use, including agriculture. So here in the US, we use 10 times more pesticides, herbicides, and synthetic fertilizers per acre on our urban landscapes than we do on the most conventional, chemically treated agricultural settings. So a field of chemical corn uses less chemicals on it than your average home lawnscape. 10 times more per square foot per square acre. And that's why we're seeing far more concentrations in our urban watersheds than we actually are in the agricultural ones.